today we'll cover part 2 of section 6.3. So what we're going to do where we left off was on example 6. And so previous to that, we learned how to convert from polar coordinates to rectangular coordinates and vice versa. So from rectangular to polar. Now, what we're going to do is not just with coordinates, but we're actually going to do that with polar equations. So right here, you guys could see these are 2 examples of polar equations, and we're going to graph them in a minute so you can see them. But before that, let's go ahead and translate the 2 rectangular equations that we have here into polar form, okay? So if you guys will have to pick one equation or function, what would you say the part A will be?
Second.
Would that be like a quadratic, an exponential function? What if I solve for y? What I get? Negative x?
It's a linear.
Linear, it's linear, yes. Thank you. How about the second one?
I thought it was.
I think it was, yes.
It's not a circle, right? No.
It is a circle, and it's actually a circle with the center. Where, guys? 1, 0. Very good, we got it. So how do you know it's 1 and not negative 1?
The opposite of the x.
So the opposite of this, right? Because the general form of a circle has x minus 8.
Wait, but what does your come from?
Which 0? Because right here, this y doesn't have anything.
Oh, so if it was like y squared plus 3, what would it be?
Okay, so if it was something like x squared plus y minus 3, and then square, and then this of 4, the center will be at 0 for the x coordinate, and then positive 3 for the y coordinate. And then the radius will be the square root of 4, which is 2. All right? So going back to the purpose of this problem. So what we're going to do is translate that into polar form. And so it is actually not that difficult. I don't know what was I thinking last time. So all it is substitution and algebra. So what we're going to be using is the fact that x is the same as r times the cosine of an angle. Let's call it theta. And y is the same as r sine theta. So what we need to do is for every x, we're going to substitute it with r cosine theta. And then for every y, we will substitute that with r sine theta. So let's go ahead and start part A. So for x, we need r cosine theta, plus for y, we need r sine theta. And so that is equal to 5. Now, I want you to look at both terms on the left side and tell me what do they have in common. They both have r. So I'm going to substitute factor out an r. And if I do that, factor out an r from here, I will get cosine theta. And if I factor r from the second term, I will get sine theta. Here I still have a 5. Now, what we need to do here is we need to leave our equation in terms of r. So we're going to solve for r. And so what is the r? What are the r and the whole expression inside the parentheses doing to each other? Multiplying. So right here, right? Because there's no sign in between. So they're multiplying. So to solve for r, it will be r is equal to 5 divided by the cosine theta plus sine theta. Yes, Viviani?
Yes.
Okay, very good. And that's it, guys. So that will be the equation. Now, we're going to graph them in polar form so that you know, you already have in your mind that that's going to look like a line, correct? Just a line. And you already have in your mind that this one is going to look like a circle. So we'll graph them in a minute so you can see. All right, now let's work with the next one. Now the next one is going to require a little more algebra. So if you want to start substituting, please, I'm going to go ahead and open the calculator just to get ready. So we're going to substitute the same thing, every x with r cosine theta and every y with r sine theta. Yes?
Why do we use cosine and sine instead of
Say that again?
why do we use cosine and sine instead of cosecant?
I mean, you could also do that. In fact, there's going to be one where we see cosecant. But just to kind of make it a little easier from where we started defining, sine theta is defined as y over r. And because cosine theta is x over r. But if you wanted to write it in terms of cosecant, then it will be like r over y.
Oh, okay.
Okay? So it's just, for some reason, they use the two main ones, sine and cosine. Okay, so let's go ahead and start substituting. Okay, so right here for x minus 1, we will have r cosine theta minus 1, and then square. Do you guys notice that? Square. And then you will have plus y squared. Instead of y, we're going to substitute that with this. R sine theta. And that is equal to 1. So for this circle, what will be the radius, guys, of that circle? Is the square root of 1, which is 1. Okay, so I'm going to expand the first expression, which is a binomial. So it will be r squared cosine squared theta. I'm going to need more space.
Isn't the r sine theta squared? Yeah.
Where?
Like, because it was y squared, so r sine theta has to be squared.
Oh, right here. Yes, you're right. Yes, thank you. Okay, so then if we square this binomial, it will be r squared cosine squared theta. Then the term in the middle, when you square binomials, remember, we can't just say plus 1, right? We're missing something here in the middle. And that something is the product of this times this, and then double. So it will be minus 2 r cosine theta. Now we square this one, and it will be plus r squared sine squared theta. And that equals to 1. Now you could see that we have two things with r squared, right? So I'm going to put them together. And then I'm going to do something. What will happen if I take this plus 1 to the other side? Minus 1, right? So what is 1 minus 1? 0. So let's just take care of that now. So that's 0. Okay, so now right here you can see that they both have r squared. So we're going to factor that out, r squared. If we factor r squared, we will get cosine squared theta plus sine squared theta. And that is equal to what?
Cosine 2 theta.
What is this equal to? What is the lifesaver? One number that we all like.
1.
1.
Isn't this also equal to double equal to cosine?
That one will have a minus. Yes, it's very similar with a minus. And so right here we have r squared minus 2r cosine theta. Is there something we could factor out?
You could factor out r.
Yeah.
Yeah, I was like saying.
So if we can factor r, because right here we have r to the first power. So if we factor r to the first power, yes, we can do that. So then we get r. If you factor r from r squared, it's like you're dividing, like r squared divided by r. So we get r right here. And if we factor out this green r from here, we will get minus 2 cosine theta. And that is equal to 0. Now from here, we use the zero factor property, and so that will break r into 2, our equation, or our 2 factors, so r equals 0. And then we get r minus 2 cosine theta is equal to 0. So here, if I want to solve for r, it will be r is equal to, we take this whole expression, which is subtracting across, and that will make it be adding, in other words, positive. 2 times cosine theta. Yes? Did we get that? Okay, perfect.
So we use that one or the R?
We will use this one. Now let me see what the book says.
Yeah, that was.
You were reading it. Okay, so the graph of r equals 0, I'm reading from the book, okay? The graph of r equals 0, this one here, is a single point. Because, okay, and do you guys remember the very first slide of this section, we defined the origin, we changed the word for that, and we call it the pole, okay? So this is what the book says. Because the pole also satisfies the equation what was the next slide, right?
Oh, that one, just scroll down.
And the book says, because the pole also satisfies this equation for theta equals pi over 2 and r equals 0, it is not necessary to include this equation, so we will not include it. Thus, the polar equation of the circle, it will just be this one here. Okay, so yes, by the book, we will not include this one, only the other. Okay? Now, let's see how they look when you graph them. So, if you could please get a calculator, that way you could stretch your legs a little bit. And if you have your own calculator, the yellow one, just keep it, so I can transfer the file right now. Well, when we're done with this lecture.
Yeah,
Okay. So make sure you all have a calculator. All right. Now, of course, we're going to go to graph. And then we're not going to enter a function. We're going to use a different type of graphing. So we need to go to menu. And then number 3 for graph entry.
Polar.
Yes, polar. We're going to use parametric in chapter 10. Okay, enter. And now, let's see if we can enter what we found. So, the first one, may I borrow your notes? Okay, so the one that we said was going to be a line, what was that? Oh, I see. So that was a fraction, so let's get that fraction tool.
So I have to do is press control.
Or I can just touch that.
Yeah.
No, I'm just kidding. Control divide? Let me try. Wow. Whoa.
Yeah, I know.
Whoa. Okay, so 5 on the numerator. And then on the denominator, we need cosine of theta. Oops, where am I going to find that? Oh, there we go. So you can press the pi symbol.
Wait, where's the theta symbol?
Press pi down here, next to the letter H. Okay, and then you select theta. Exit out of that parentheses, and then plus sine.
You can see me spell sign. Yes.
What?
Sine theta?
You just spell sign.
Don't say cos.
You're not recording, are you?
Oh, wait.
Yes, I'm recording. And we do get the line, right?
Yes. So I can do.
Hey, my line's small.
Yeah, I know.
What did I do?
It's 5, and then cosine theta plus sine theta on the denominator. Now, yes. Okay, if you're getting something weird, like the student here whose name I'm not going to mention, go to your settings and make sure you're in radians. It could be that.
Wait, put that on the almost and see what you do. Just make sure I didn't get it.
Oh, it's just nothing.
We have a dog.
And it works in degrees? Oh, okay, so then that has nothing to do? Then I don't know what she did. We don't know what the student did.
You should have entered theta. I did put theta. It's like a little tiny line there.
Yeah. You're doing like.
Oh, you guys want to see what Biryani got?
I thought you were going to say my name.
I'm sorry, the student. So you guys could see she entered it correctly. However, that's all she's getting. So I really don't know what she did. Let's check.
It's the same function. It's just tiny. Oh, maybe your setting's the parameter of the line.
Uh-huh.
Where's that?
Right here.
I didn't change it.
No, it's good.
Let me see your settings.
Oh, no, not those settings. The actual settings for the graph itself.
Oh.
Exactly like that.
It's exactly.
That's 6.28.
And the step? What about the step?
Yeah, it's all like that.
So what did she do?
Maybe it's the calculator.
Because I went to window and standard. See? I don't know, Biryani. Okay, guys, could you please try to graph the other one and see if we actually get a circle like we had predicted?
Wait, do we just flip this one?
Okay, that one was the first one that we said is going to be a line, right? This one right here. You guys remember we predicted it's going to be a line? So even though we graphed it as a polar equation, it looks like a line. With the y-intercept at 5 and with the slope -1. You can see here the y-intercept clearly at 5. Now, if you could please, you could just delete that one.
Do we type in cosine theta?
Yes.
Yeah, mine didn't work. I'm thinking it's like my my circle is the range. The range?
I try to change it to normal windows. Okay, what was the other equation, guys? Could you please?
It's 2 cosine theta.
Whoa.
See, it's not me.
What?
That's cool.
That was your name.
Thank you.
Oh my god.
I was talking to you. Great time. What, 2?
Okay, what is the second equation, guys? Cosine?
Yeah. And then theta. Oh my god.
That's it?
Theta.
Wait, 2 closer?
Okay, you guys sound like you're having too much fun. I know it's not for math.
Mine didn't come out with.
No, you didn't get it?
I got a circle.
Mine's just a dot.
Okay, I need to check your
Zoom in.
settings
Yeah.
for graph,
Go
for
to,
graphic.
Maybe I gotta zoom in.
go to menu and then put analyze graph.
So you guys remember, we predicted it's going to be a circle, I'm still talking, with the center at 1, 0, right? Is that what we said? Or Miguel told us or someone?
Yes.
Center at 1, 0 and the radius was 1. And yes, that is what we get. We can verify it here with that graph. Okay, now let's finish 6.3 quickly. And so now we're going to do the opposite. We're going to go from polar to rectangular equations. So now we're going from polar to rectangular. And make sure that you guys, when you're doing your homework, you're looking at your notes and not just at the example. Okay? You need to make, or Mathway, please. Because Mathway, it might not always give you the correct answer.
So you check this.
Yeah, yeah. And so Mathway is not going to take the test for you, unfortunately, right? That will never happen. Okay. So, yeah, right.
I don't even know what math is. It's a website where.
You sure?
You're the one that doesn't know. When you input the equation. I don't remember that.
Yeah, and that's why you guys get so great exam grades on the exams, because Mathway is teaching you so well.
No, because it's really
I didn't know I could anything on the weekend.
See, I was like, I'm not even.
Okay, I need you guys to let me finish this section so you can take a break and then you can watch 6.4 on your own.
Yeah.
Alright, so what we're going to do here is for the very first one, we're going to use the relation of the circle that says the following. X squared plus y squared is equal to r squared. Alright? And so what we're going to do, okay, so what we have is this right here. So we have r is equal to 5. So I want you guys to do the same steps I'm going to do. First, I want to square both sides.
Why would you do that?
Because I want to. No, to answer your question, because I want to get to this.
Oh, okay.
So then I get r squared is equal to 25. Yeah? Are we good? Now, what I want you guys to do is replace. Here we're saying that the left side is equal to the right side, correct?
Yeah.
So what we're going to do is replace the r squared with x squared plus y squared. And so that will be x squared plus y squared is equal to 25. And so I could tell you right now that that will be a circle. Where will the center be?
0, 0.
At 0, 0. So this is a circle with the center at 0, 0. And what is the radius of the circle going to be? 5, right? The square root of 25. Now, let's think about it. And this polar equation just says r equals 5. And you don't need to copy this. Okay. So basically, what this equation is telling me is that it doesn't matter what the angle is, you will have all these little points at r equals 5. So when you keep plotting points all around, you keep doing that, that's what takes shape of a circle.
Wait, so if you look close, you'll see.
Yes, it will be a circle. Huh?
So if you zoom in far out on a circle, it's gonna go.
Well,
It's because they're infinite points.
well, those are some of those trivial questions in math. They're like, you could say like the numbers from 0 to infinity are infinitely many. But you could also say the numbers from 0 to 1 are also infinitely many. I know. To compare it to something rectangular, do you guys remember when we had, let's say, vertical lines like x equals 5? And I used to tell you it doesn't matter what your y is, your x points will always be here. So if you put them together, that's how you get vertical lines. Okay? All right. But to answer the question, which was convert to rectangular, this is the answer. That's the answer right there. This is polar form. This is rectangular form. Okay, so let's do part B. So you guys can all take a break. Now, in this case, we only have theta. And so what we're going to do, we have theta on one side, we have pi over 4 on the other side. So what I want to do is write down, take the tangent on both sides. As long as I do it to both sides, I'm okay. Now, I know Sean knows the answer to this question. What is the tangent of pi over 4? Very good. So 1. And then from there, what do we do next? Okay. So now definition of tangent, remember we're going to rectangular, right? So in other words, we don't want to have theta, we want to have x and y. That's what we want. So in terms of x, y, and r, tangent is defined as what?
Y over X and R.
Y over X.
Y over x. Y over x. And then right there, could I solve for y?
Yes, you could.
Yes, because the x, what is the x doing to the y? Dividing, so we need to multiply. So 1 times x, so y equals x. So what kind of graph will that be?
Linear.
Just a linear, right? Just a line. Very good. All right, the third one, which is C, that will be r equals 3 times the cosecant of theta. Okay, so what we're going to do first is use the reciprocal of cosecant. So what is the reciprocal of cosecant? Sine. So this will be 3 over sine theta. Okay, now what we're going to do is take this sine theta. What is the sine theta doing to the 3? Dividing. So if I take it across, what's going to happen? Multiply. So we will have r times sine theta equals 3. And by definition, what does that equal to? Y. So y equals 3. And so if we were to graph that, that would just be a horizontal line. Okay, and the very last one, which is r equals negative 6 cosine theta. Let's do something similar where we change, no, actually not. Let me see, what do we do here? Oh, okay. So we're going to multiply. I'm going to need a little bit more space. So we're going to multiply by r here and also here. So on the left side, we are going to get r squared. On the right side, we're going to get negative 6r cosine theta. Why did I multiply by r? Because I want to get this. r cosine theta, because that could be substituted with what? X or Y? With X. So r squared is equal to negative 6x. And then r squared is going to be substituted with, do you guys remember this equation right here? X squared plus y squared. So x squared plus y squared is equal to negative 6x. And then, oh, we gotta do all this stuff. Okay, so I'm gonna need more space for that, okay? I'm gonna take it here, so we have x squared plus y squared is equal to negative 6x. So you could start to see that we're gonna get a circle, right? However, we don't know where the center is. And so what I'm gonna have to do is, what is this thing called? Complete the square.
No, it's actually called a zoe.
No, that's the actual term. We're going to use this a lot in chapter 10, so let's just go for it. Okay, so this is what I want to do. I want all my terms that contain a variable on the left. Okay, so x squared, and then I'm going to take this negative 6x, take it across. So that will become plus 6x. Then I'm going to leave a little space here, and then I will have plus y squared, and that will be okay. Now, what do I have on the right side so far? Nothing, 0. Okay, now complete the square. What you do is you take half of 6, of positive 6 in this case, and you square it. I think so. So that's going to be x squared plus 6x, and Peru is telling us half of 6 is 3, so we're going to be doing this. 3 squared plus y squared. Now, since we added 3 squared to the left, we must add it to the right as well, like that. And this is x squared plus 6x plus 9 plus y squared is equal to 9. Now, what I'm going to do is take the first term, that trinomial, and I'm going to factor it. That is actually a perfect trinomial square. So I'm going to factor it so that it looks like this, like a binomial square. So it will be x plus, and the number that I'm going to use is actually this number, 3. And that's it. That's how we get the equation of our circle. The circle happens to have a center at negative 3, 0, and the radius is 3. Why is it 3? Because it's the square root of 9. So I'm going to move this in case you forgot to, or you missed something on the board. Okay, so I'm going to pause the video, and then we'll take a break while the video is processing.